Hey everyone, welcome to Code Harmony. Today we are solving this question 2127, maximum employees to be invited to a meeting. This question has been asked in good companies like Google, Uber, Microsoft, Amazon, and it is based out of graph cycle especially. Let's have a look on the problem statement. They are saying that a company is organizing a meeting and has a list of n employees waiting to be invited. They have to arrange a large circular table. Okay. They are having n employees and they are going to have a large circular table. The employees are numbered from 0 to n minus 1. N employees from 0 to n minus 1. Each employee has a favorite person and they will attend the meeting only if they can sit next to the favorite person at the table. Every employee I will only be attending the meeting if I is able to sit with its favorite person beside the table. Let's say I has a favorite person, let's say J. So J either be sitting in this side or in this side. Only in that case I is going to attend the meeting. And the favorite person of the employee is not themselves. Okay. So it's a different person always. Now given is zero index array favorite. Favorite I denotes the favorite person of ith employee and return the maximum number of employees that can attend the meeting. So this is the problem statement. Let me explain it to you with the help of an example. So first of all, what is given to us? What is given? Given is an array, integer array, where values in the integer array is the favorite person of ith employee. As it is already mentioned that we are having n employees. Employees are from 0 to n minus 1. So these are mapped to the indices 0, 1, 2, 3. These are the employees 0, 1, 2, 3. And the values are their favorite employee. So the 0th employee has a favorite employee 2. 1 has a favorite employee 2. And 2 has a favorite employee 1. And 3 has a favorite employee 2. Okay. Apart from 2 is favorite of every other employee. Okay, in this case. This is given to us. What is our operation? What operation or what work we have to do in this problem statement with this input? Invite employees if and only if they can sit next to the favorite person. So 0th employee, 0 number employees are going to attend the meeting only if its favorite employee is also attending the meeting and sitting beside 0 on the round table. So 0 has a favorite 2. So 0 is only coming if 0 is able to sit with 2 on the table. And 1 is only going to attend the meeting if 2 is sitting next to it. So 1 should be coming here. So in this arrangement, 1 is sitting next to 2. 1's favorite is 2 and 0th favorite is also 2. And now what about 3rd? 3rd favorite is 2, but 3 cannot sit next to 2. So 3 is not coming in this arrangement. So this is our arrangement that we can do, and we don't have any other arrangement where the number of employees are more than this. We are already attending 3 employees out of 4. So our answer would be, what are the maximum number of employees we can invite? Okay. So this is our problem statement. We are given employees from 0 to n minus 1 and their favorite employee. Every employee, let's say ith employee is going to have J as a favorite employee, and I is only going to attend the meeting if J can sit next to I in the meeting. It means, let's say if a person, let's say K, is favorite of more than 2 employees, but in the arrangement K can only sit with 2 person, one on the left side and one on the right side. So this we will have a look later on in the in the approach section, but now we just have to understand the problem statement. So this is the given part, this is the operation, and this we have to return, and maximum number of employees can be invited. Okay, this is an integer value, so this integer value we have to return from the function. I hope you understood the problem statement, and now we will try to understand it further with the help of an example. We will try to map this example to the table and see how many employees we can invite. Okay, so this favorite array is given to us, and this favorite array values are the employee's favorite employee. and these are the employees 0, 1, 2, 3, 4. So we are having 5 employees, number from 0 to 4, and their favorite employees are. Now let's try to map this value in form of graph. So for 0, favorite employee is 3. 0 to 3. Yeah, this is the edge. 1 has a favorite employee of 0. So this is the edge. 2 has a favorite employee 1. So 2 is pointing to 1. 3 is pointing to 4. Okay, this is the case. And 4 is going to point 1. So this edge, this final edge. And now we have to find the maximum number of employees we can attend to the meeting. And in the meeting, we are definitely going to have a circular table, and we are going to arrange these employees around this circular table. So if you just try to have a look, and that one constraint we have to keep in mind, that I should be sitting next to its favorite person. That is for sure. And every employee who is attending the meeting, he should have a favorite employee, and the favorite employee is sitting next to it, either on the left side or the right side. Okay, if we try to map it, what I'm seeing is that 1 has a favorite employee 0. If we are choosing 1, we have to choose 0 as well, and we have to choose 3 as well, because 3 is favorite employee of 0, 4 is favorite employee of 3, and 1 is favorite employee of 4. So if we are choosing 1, we have to choose everyone. It means this form of cycle we are seeing in this diagram, this cycle we have to map it. It means 0 we have to pick, 3 we have to pick, 4 we have to pick, and 1 we have to pick. It means that if all of these employees are making a cycle, why not I just pick this cycle and map it to the table? 0 employees sitting here, 3 employees sitting here, 4 employees sitting here, and 1 employee is sitting here. And now my arrangement is perfectly fine. 3 is the favorite of 0, 4 is the favorite of 3, 1 is the favorite of 4, and 0 is the favorite of 1. This arrangement is looking perfectly fine, and in this arrangement we are able to map only 4 employees. Can we incorporate 2 as well? See, 2 has a favorite employee of 1, and 1 have both the places on the left side and the right side occupied. So 2 cannot sit beside 1. So 2 is not going to come in our meeting, and these 4 are attending the meeting, and my answer would be 4 in this case. Okay, so this is our example, and from this example, if we try to analyze it further, also in this example, we are seeing that whatever items are forming a cycle, we have picked those items and mapped those items to the table. So one option we are getting is that option 1, choose cycle in the graph. And if we are picking the cycle, why not we just pick the largest cycle? Because if we map the largest cycle, maximum number of employees we are going to invite in the meeting. So why this is the largest cycle. So option 1 we are going to have is choose the largest cycle. Largest cycle. Let's say 1 is dependent to 2, 2 is dependent to 3, 3 is dependent to 4, 4 is dependent to 1. And in other case, let's say 6 is independent to 7, 7 is dependent to 8, then 9, then 10, then 6. So in this graph, we are having 2 cycles, cycle 1 and this is cycle 2. But we are going to map cycle 2 on our circular table, because cycle 2, if we try to map on the circular table, it is going to give me the answer which is equal to 5. So we have to think greedy in this case. And our first option, and why I'm telling it first option, we will have a look later on. So this option is choose the largest cycle in the graph. And what is this graph? There are n number of edges, and they are edges from U to V with a specific direction. We can call it a directional graph. So if we try to break down this problem into the subproblem, one problem we are encountering is that we are given a directional graph and we have to find the largest cycle. And even if we are finding the size of that cycle, we are good to go. So this is our problem 1 that we have to as a mandatory step to solve this problem. Okay. In the directional graph, find the cycle of given size, and this is a standard problem of finding cycle in a graph. This you can do either with BFS or DFS, or if you are aware of that algorithm, topological sort you want to do, you can do that. 2 days back we solved a problem where we encountered DFS and we used DFS to find the cycle in the graph. So this approach, the same approach we can use here, and we will have a look later on. But before that, I would like to have one more example to understand it better. Now my second example is this. These are the favorite employees, and these are the employees whose favorite employee is this. So employees from 0, 1, 2, 3, 4. And if we try to map these employees as a form of graph, it will look something like this. Let me draw the graph. 0 is having a favorite employee, which is 2. Let's say 0 is a node here, and 0 is pointing to 2. One directionalized from 0 to 2, from 1 to 2 as well. So 1 to 2, and from 2 to 3. 2 is going till 3, 3 to 4, and 4 to 3. 4 to 3 mean, now just think what I have done. We are given an array, and from this array I have prepared some kind of adjacency, or you can say graph I have prepared, and graph is always represented in adjacency. So in short, the very first step that I have done is step 1, which is prepare adjacency list, you can say. So this adjacency list I have prepared, and from our previous example we got to know that if we are able to find the largest cycle in the graph, we are able to get the answer. The size of the largest cycle is going to be my answer. But in this case, let's say this is our rounded table in the meeting, and I can see that there is only one cycle from 3 to 4. Only one cycle is there, and if there is only one cycle, the largest size of the cycle is 2. And if I just map 3 and 4 in this case, then my answer would be 2. But here, if you try to analyze that 3 has a dependency on 4, 4 has a dependency on 3. Okay. But in the above example, 0 has a dependency on 3, and 3 has a dependency on 4, 4 has a dependency on 1, 1 has a dependency on 0. We are completing the whole cycle. We are completing, and there is no space to add another employee. And in this case, even if these two employees are sitting in a corner or at some piece of the of this circular table, let's say 3 is sitting here, 4 is sitting here, the rest of the table can be utilized by some other guys. It means that there is something that we can do better. So finding the largest cycle is not the good option. But if this is a cycle, and let's say if I introduce one more employee into this, let's say one more employee is, I'm just taking an example. Example I'm taking is, let's say 3 is dependent to 4, 4 is dependent to 5, 5 is dependent to 3, and this is a cycle of size 3. So 3 and then 4 and then 5. 3 is dependent to 4, 4 is dependent to 5, 5 is dependent to 3. We are utilizing the whole circle. It means when the employees count in the cycle is greater than equal to 3, or in other words, when it is greater than 2, in that case we have to utilize the whole circle. But there are some cases when the cycle size is equal to 2, or one cycle does not exist because there is no self loop. This is already given in the problem statement. So there is only one possibility, when the cycle size is 2. In that case, we can attach other candidates as well. So 0 has a dependency on 2 and 2 has a dependency on 3. Okay, if 2 has a dependency on 3, I can add 2 here as well, because 2 has a dependency on 3. And what about 0 and 1? I can either add 0 here, or If not 0, then I can add 1 here. In short, what I'm doing in this case is a bit different from the previous case. In the previous case, we have just picked the cycle, and in this case we are also having a cycle, but the cycle is of size 2. If the cycle is of size 2 on the whole table, we are not utilizing the complete space. This is one employee, this is second employee, connected to this favorite employee. This one has a favorite employee 2, 2 has a favorite employee 1, and our rest of the table is empty and can be utilized by some kind of chain attached to this cycle. Okay, so in the previous example there is only one cycle because the cycle size is greater than 2. If it is greater than 2, then this is the only option we have. If the size is equal to 2, then we are getting some possibility of attaching more items. And what are those more items? Maybe any kind of chain. This is the chain. This is a chain starting from 0 and ending till 3. The 0 or 1, 0 or 2 you can say, whatever you want to do. This chain, this 0 and this 2, and this is attaching to 3. And this is attaching to 4, and this is a cycle. So this cycle, this portion is being attached to the cycle. If this portion is attached to the cycle and the cycle size is equal to 2, we can add this portion also on the table. And what if we don't want to take this like portion? Then we can choose this portion instead of that portion. 0, 1, 2. So 0 and then 1, and this is also attached to the cycle. But luckily in this case, both the chain, let's say this is chain 1 and this is chain 2. Both the chain 1 and chain 2 are of size 2. But if in some cases when other chain is of bigger size, we are definitely going to go pick the bigger one. Okay, in this case you need to note one thing, that this is a chain, like from this, and this is the chain, and this is the starting node and this is the ending node, or you can say this is the ending node. This ending node is attached to a cycle. Okay, ending node is attached to a cycle and the starting node is not attached to anyone. And how do we choose the starting node? Starting node, if you try to analyze the starting node, there is no incoming edge in the starting node. So starting node is something which is having in degree equal to 0, in degree equal to 0, and the ending node should be attached to a cycle, and this is going to be called a chain. So now we have gone through two examples. One example is this one where we just directly pick the chain, and second example is this one. And now just try to analyze what we have done. We are given a favorite array, and throughout this favorite array, what is our first step? First step is we have prepared the adjacency, and then the second step is find largest cycle size. This is something we have to get. Largest cycle size, this is one possibility 1, and there is another possibility of from the second example, or maybe you will just get another possibility where the chain size, cycle size is equal to 2. So pick this cycle and pick any chain attached to it. This is the cycle and this is the chain. So what you have to get is find the longest chain. Find longest chain. Let's say longest chain is having 2 number of employees, and 2 employees are there in the cycle because cycle size is also 2. So 2 plus 2. This is also one option. And now from this possibility 1 and possibility 2, whatever is the maximum, I'm going to pick that as my answer. So this is our problem statement. So this is our approach to solve this problem. And preparing adjacency. See, if you are given a graph and you are preparing adjacency, why do we prepare adjacency? This is used to to handle graph, to store graph. And preparing adjacency is one step we have to do. Finding the largest cycle size. Finding the largest cycle size is second problem we had to do. And the third problem is finding the longest chain. Longest chain, that is starting from a node which is not having any in degree and ending to a cycle. This is a kind of chain we have to get. Now we just have to solve two problems. Finding the largest cycle in the graph, and second one is finding the longest chain. Firstly, let me help you have a quick revision about the finding the cycle. When we find the cycle using DFS, we maintain two kind of variables, like or maybe let's say flags. One is visited, which is a global visited, tracking which node have been visited, like in respective of the DFS call, and the current visited to track the visited node in the current DFS call. And we are going to start the DFS call from every unvisited node. This is unvisited. Visit this node, mark this node as a current visited within the loop, and let's say you are capturing the time as well, because you want to find the cycle length, and cycle length is equal to the number of edges between it. Let's say with every edges we are increasing the time by 1 unit, and this node we have captured at time 1, and after 1 unit of time I'm going to capture the neighbor of 0. Neighboring node of 0 is 1. 1 is visited, current visited, and it is captured on the size 2. Visited, current visited at size 3, or you can say time 3. Visited, current visited, time is increased by 1 more time, and after 3 we are having two possibility, going to 4 or going to 5. If we are going to 4, then nothing is going to happen if we go to the neighbor which is 1. Here in this case 1 is currently visited within the same DFS call. It means that it is causing a cycle. If it is causing a cycle, we have to figure out the length of the cycle, and length of the cycle is equal to number of edges between it. 3 node is captured at time 4. 1 node was captured at time 2. It means we need to capture these times also somewhere. So let's say time is also some kind of array, and what we can do is time of 3 minus time of 2 plus 1, because we have to include both the nodes. 4 minus 2 plus 1, which is 3. Now 3 is the size of this cycle. Okay, in this way we are going to capture every single cycle, and we can maintain some kind of variable. Let's say L1 is the variable to capture the maximum size of cycle. Okay, so this L1 is captured. Let's say L1 is 3 in this case. Now we have to find the longest chain, and longest chain is something which is starting from any node with in degree 0, starting with in degree 0 and ending at cycle. Ending at cycle. If it is ending at cycle, it means that for that element in degree is not going to be 0. Let's have an example. Let's take the same example. 0 and 1 both are pointing to 2, and 2 is pointing to 3. 3 is pointing to 4. 4 is pointing to 3 in this case. Here, what is the current state? Current in degree count. In degree count of 0 is let's say 1, 2, 3, 4 and 5. These are the 5 elements, and what are the node values? 0, 1, 2, 3, 4. Indices are the node values from 0 to n-1, and 0 have a in degree. This array is for in degree. 0 have an in degree of 0, 1 has an in degree 0, 2 has an in degree 2, and 3 has an in degree 1, and 4 has a 3 has an in degree 2, and 4 has an in degree 1. We have captured the in degree, and along with the in degree, let's say we are already capturing the current chain starting from 0th node, 1, 2, 3, 4, like this. So in this case, how we can do or proceed further? We are definitely going to start our chain from a node which is having in degree 0. It means these two nodes can be our starting node for the chain. And if these are the two eligible nodes, we can have some BFS kind of approach. We are maintaining these two nodes in a queue 0, 1. Okay, and when we are processing 0, and find the favorite employee of 0. Okay, favorite employee of 0 is 2. Now see whether 2 has already some kind of chain associated with it, and there is no chain associated with it. So currently chain of 2 is 0. Okay, this is the existing value, and the current value is chain till 0 plus 1, chain till 0 plus 1. This is another value. So whatever is the maximum value, we are going to put back to the chain array, and this chain array is going to maintain the size of the chain. Okay, so 0 has a favorite item, 2 favorite employee, 2, and this employee have an existing value 0 and the new value is 1. It means that there is one size chain ending at 2, which I can show here in the diagram, in the graph. This is something we have captured right now because we have processed 0. And now as we have processed 0, just decrease the in degree of 2. In degree of 2 has been decreased from 2 to 1. Why? Because if at any moment, if its in degree is becoming 0, this can also behave as a starting of the chain. So now in this case, when we are processing 1, it means the chain 1 has a neighbor of 2. It means chain of 2 existing value plus chain of 1 plus 1. Chain of 1 is 0. 0 plus 1. 1 is one possibility. Chain of 2. Existing value of chain of 2 is, this is giving 1 and 1 was updated here. 1 is the value. So whatever is the maximum, just update it. Both are same. So 1 will be updated here and it will remain 1, and in degree of 2 will now become 0. And now if in degree of 2 has become 0, now we will start our chain from 2. So it means 2 is inserted into the queue, and now when you are processing 2, you have a favorite employee 3. So chain ending at 3, what is the value of it? Maximum of chain ending at 3 current value, or maybe chain ending at 2 plus 1. Now change ending at 2 is already captured in this array, which is of size 1. So it is 1 plus 1, and change ending at 3 is 0. So it is 2. It means that 2 value will be updated in this array. At this moment we are having 0, 1 and 2. And in this case, after 3 in degree is reduced to 1. And now at this moment we don't have any other in degree. It means we have captured all the chains, and this is the final array: 0, 0, 1, 2 and 0. Employee 0, employee 1, employee 2, employee 3, employee 4. What I can see in this case, at 3 there is a chain ending of size 2. Okay, and as you can see from this, 3 and 4 are a part of 2 size cycle. 2 size cycle mean this is the table, 3 is here, 4 is here, 3 is dependent to 4, 4 is dependent to 3, and there is one size chain ending at 2, but 2 is not here. 0 size chain ending at 4, that is not something we have to bother about, and there is 2 size chain which is ending at 3. Ending at 3 means there is 2 size chain ending at 3. Either it is this one or this one. Whatever you want to take, you can take. Ultimately we have to give the answer. So 2 size chain are attaching here, so you can just use 2 and 0. So what I can do is 2 map to 3 and 0 map to this one. So my answer is 4. So these are my two approaches. These are, you can say, two sub problems. First is finding the longest cycle and finding the longest chain. Finding the longest cycle, finding the longest chain, and in the end, what is the answer of my problem? And my problem answer is maximum of finding the longest chain is L2, finding the longest cycle is L1, the maximum of L1 and L2. This is my final answer. Now the problem is done. This much you have to understand, and let me show you the code for this approach. Okay, so this is the code that I have written in my style. What is the step 1? Whatever is the given favorite array, just prepare the adjacency. Preparing adjacency is not that difficult, and this step is done. And after that, find the longest cycle in this graph. This is a standard problem. And third step is handle chains and 2 cycle. You just have to find the longest chain which is ending at a cycle, and after that, whatever is the giving me the maximum value, longest cycle or the chain, that is going to be my answer. So how do we find the longest cycle? Cycle we can find using DFS, starting DFS from every unvisited node, and we are just doing a DFS using two visited arrays. One is visited and second one is currently visited, and this discovery time I am encountering this array to capture the time. Let's say one item is visited again, and I will be able to figure out like what is the delta, what is the difference between the time. Okay, so this is the approach for finding the longest cycle, and this is my handle chains and pairs. For this I firstly require in degree array. Why? Because if any item is having an in degree equal to 0, only from that employee or node we can start our chain, and then we can do some kind of BFS like approach using maintain a queue, and from the queue just process every employee with in degree equal, every node with in degree equal to 0, and just decrease the in degree once you have utilized that favorite item or favorite employee. And now what is this code? See, we are capturing chains where the chain is starting from an item with in degree is equal to 0 and ending at an item which is part of a 2 size loop. 2 size loop means let's say my favorite, let's say ith employee's favorite employee is J, and jth favorite employee should be I. With this condition, favorite of I favorite is equal to I. This is a 2 size loop, and this is just to avoid the duplication, and this is the condition, main condition. And if this condition is getting satisfied, it means that let's say I and J are following this condition. So I is already there and J is favorite of I. So IJ, chain ending at I, chain ending at J, and just capture the chain which is ending at this one. Okay, and you have to capture all the pairs. It means all the 2 size loop can be incorporated over the table. All the 2 size loop with a chain ending to it. And in the end, just total pairs and chain. This is going to give me the employee count that can fit, and whatever is the maximum, total pair and chain, and total length of cycle, whatever is the maximum, I can return from this function. Now I will just attach this code in the description. You will find the code and just try to understand it further. And if you are finding it difficult, then I would suggest go through the sub problems. Firstly, just try to find or do the problem like that, finding loop in a directed graph like this. If you still get any doubts, you can comment down below, or maybe if you are following some kind of different approach, let's discuss that in the comment section or in the Discord community. Okay guys, bye bye.